Hello students, in this video I'm going to go through some examples on how to graph the equation for an ellipse. Now the instructions here says to identify the vertices and foci of each and then to sketch the graph. I'm not going to identify the foci. I'm just going to identify the vertices, okay, and sketch out the graph, okay. There's a bigger discussion, okay, that needs to be said about, the location of the foci for the various different conic sections, but that's left for, I think, maybe in the pre-calc course, okay, if your teacher decides to get there. But for the time being, okay, what you need to be aware of on how to graph these things is to locate some of the key elements, okay, that will pinpoint where the graph will pass through, as I'm going to demonstrate right now. So let's take a look at the first one here. So what I have here, okay, is x squared over 20 plus y squared over 10 is equal to 1. So what this is, okay, if you were to figure out what the where the center of this ellipse is, if you recall in the previous video that the general equation for an ellipse looks something like this. Immediately, okay, upon inspection, I can tell where the center of this ellipse is going to be located. This is going to be 0, 0, just because nothing is being subtracted from x or y. Now, the next thing I'm going to do, okay, is I'm going to gather other clues about this equation, and that is, well, how does a graph, like, pass, which points, okay, will this graph actually pass through? And like any situation, if you don't know something, okay, the one thing that you can always do with no fail is to substitute in points and try to determine from there, okay, where the what the coordinates of the graph is. So I'm going to decide to use very strategically to find out where the x-intercepts are and where the y-intercepts are. So to find the x-intercepts, the y-coordinates must equal to what value? It must equal to 0, right? So in order for us to find out what the x-intercepts are, I'm going to substitute in 0. And if I do that, I'll get x squared over 20 is plus 0 over 10 is equal to 1. Or x squared over 20 is equal to 1. And if I cross multiply, I get x squared is equal to 20. Take the square root of both sides, I get x is equal to plus or minus square root of 20. And square root of 20 reduces to plus or minus 2 square root of 5. And what exactly is that? That's like somewhere close to 5, but not quite, okay? It's like 4 point something-ish, okay? So let's punch what that is into the calculator. So I have 2 square root of 5 is 4.47, so roughly 4.5. Okay. So it's going to be like right there, positive, and right there, negative. I want to do something really similar to find out the other vertices, okay? So what is that? So I'm going to do y squared. I'm going to replace x with 0, and I'll end up with y squared over 10 is equal to 1, or y squared is equal to 10, or y is equal to plus or minus square root of 10, which is going to be a little over 3. Because I know square root of 9 is 3. So what is that roughly, right? Square root of 10 is 3.16. And we're drawing this, okay? So roughly there, thereabouts, and roughly there, thereabouts, okay? If you're making a sketch, nothing is going to be ever going to be exact. You're not a computer. The idea is you want to get a general sense of how this picture is going to look, and that's what this is going to do for us. By picking strategically, we can get a good sense of what the graph is going to look like. So that's the shape of the graph. All right, let's move on. Let's do this one here. X squared over 4 plus y squared over 9 is equal to 1. So again, very similar. Okay, what I want to do is I want to substitute in 0 in for y and substitute in 0 in for x, and then solve for x and y respectively. So if I do this, substituting 0 in for y, I end up with x squared over 4 is equal to 1, or in other words, x is equal to plus or minus 2. And I do the same thing. I say y squared over 9, substitute in 0 for x, I get y squared over 9 is equal to 1, or in other words, y will equal to plus or minus 3. If you notice in this case, the ellipse, okay, is oriented slightly differently. It's kind of strange to think about like the orientation of the ellipse, but certainly in any ellipse you're going to have one axis going to be longer than the other, right? The major axis is what we call the longer axis, is larger in the vertical direction in this case. Over here, the major axis is longer in the horizontal direction. So we actually describe this ellipse as being oriented vertically, whereas this ellipse over here is oriented horizontally. Anyway, the reason why I skipped, or I had you guys not work on not finding out what the foci are, okay, is because depending upon how the orientation of what the orientation of the ellipse is, okay, that will determine the location of the foci as well. So, but again, that's left for a much larger discussion later on, perhaps in pre-calculus. Anyhow, so getting back to this, so very similar. Okay, we can do something similar in this example. I'm going to find the x and y intercepts again. If I find the x-intercepts is located at 1 and -1. You see how quickly we can do this now? The y-intercepts are located at plus or minus 7, so it's over here and down there. So this is, again, a vertically oriented ellipse. And again, I know it's vertical because the major axis is oriented vertically. All right, let's look at another example now. All right. So in this case, the center of the ellipse, okay, is shifted. If you look at these examples here, let's take a look at this first, number 7 over here. The general equation one more time for writing the an ellipse looks something like this. And we can immediately identify what is the center of this ellipse. It's going to be located at 0, positive 2. Right? So again, okay, we can do something very, very similar, okay? So if you look at this, okay, my horizontal axis and vertical axes, okay, is going to pass through 0, 2. So if I substitute in strategically, okay, y equal to 2 into there, then the whole second term on the left side of that equation will go to 0. And that is purposeful because I want to figure out what are the x-coordinates to the left and right of the center. So in this case here, x will be plus or minus 4. So it's going to be located over here. And then similarly, okay, I'm going to substitute in 0 in for x, right? So when I substitute in 0 in for x, okay, I'll end up with y minus 2 squared over 25 is equal to 1. And again, I want to solve for the y's, right? So I have y minus 2 squared is equal to 25. Take the square root of both sides. I get y minus 2 is equal to plus or minus 5. Add 2 to both sides, I end up with y is equal to 7 or -3. So 7 is located here, and -3 is located over here. So this is going to be the graph of my ellipse. And again, it's oriented vertically. I don't know if you have, if you've noticed the pattern. Whenever this number underneath the y, right, is larger than this guy, then we are going to end up with a vertically oriented ellipse. All right, let's take a look at another one. Let's do this guy here. Okay, so what we can also do, instead of identifying where the center is, let's think about this maybe not graphing this exactly the way we see it, but let's maybe think about this as a transformation. So this is an alternative way of thinking about this. You can also think about graphing this guy first and then performing a transformation. Okay, and this can actually cut down on some of the mathematics. So if we graph this equation here, oriented in the center, and then shift it, okay, perhaps that can be a little easier. So here I can tell if I substitute in 0 in for y, my x's will be, what will that be? I'll end up with x squared over 25 is equal to 1, or x is equal to plus or minus 5. If I substitute in 0 in for x, I'll end up with y squared over 4 is equal to 1, or y is equal to plus or minus 2. So in other words, okay, my center here is located at 1, negative 5, right? So it's 1, negative 5. From the center, okay, to the left and right of the center, I'm going to go 5 units. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. It's going to be over here. And then to above and below the center, I'm going to go 2 units up and 2 units down. So this is going to be the location of the graph of the ellipse. And that's how it's going to look. Let's try that one more time. Okay? Of course, if you graphed out, this the way it is, you'll end up with the same kind of answer that I just came up with, right? But again, it's the same concept. So this was what it would have been graphed where the center is located in the origin. Right? We move 1 unit to the right and 5 units down. Same thing. Okay. Let's take a look at this guy. All right. So again, I want to treat this as if it's graphed in the origin, and I can tell immediately from this that x will equal to plus or minus 1, right? And y will equal to plus or minus 2. And the center is located at negative 2, positive 5. So negative 2, positive 5 is located over here. So on the center, I'm going to go 1 unit to the left and 1 unit to the right. And I'm going to go 2 units up and 2 units down. And this is going to be the shape of my graph. And again, just like before, it's very fitting to that pattern. If the number underneath y is larger than the number underneath x, we can tell then the ellipse is going to be vertically oriented. All right.